Hello, my Algebra 2 students. I hope you are doing well. I have Teddy sitting at my feet, so hopefully he will behave. We are doing multiplying and dividing rational expressions today. So I wanted to start with a really easy example to kind of show you two different ways that we can approach these. So first example is 3/8 times 10/3. The first method when you're multiplying fractions or rational expressions is that you can multiply across the numerator and across the denominator to come out with a product of 30 and then 24. And then from there, you can simplify. So you could then say, okay, I can break this into 6 times 5 and break this into 6 times 4, simplify out those common factors, and there you go. And we would get 5/4. So first step would be to multiply across, and I'm going to make it simpler, the top and the bottom factor. Simplify. Your other option, so I'm going to say or, second way to approach the same exact example. Let's go 3/8 times 10/3 would be to say, all right, well, instead of doing this, let's factor it first. And so if I take this and factor it first, 3 is already factored. I can factor 10 into 5 times 2. 8 factors into 4 times 2. And then I have the 3 here. And then what I can do is treat it like it's one big fraction. So one big old fraction here, right? And then what we would do is simplify anything from top to bottom. So simplify any common factors from numerator to denominator. I'm just writing top to bottom because it's faster, all right? So essentially like cancel the factors. And so in this case, I can cancel out the 3's. There's a 2 in the top, 2 in the bottom. I can cancel out the 2's. And so all I'm left with, because you're leaving 1's in place of all of those, is just 5 by itself times 1, and then 4 times 1, or 4. So same answer, two different ways to approach it. So here we factored first, we simplified anything out, and then anything that's left over, we would multiply together. So multiply any remaining factors together, and that'll give you your answer there. All right. The reason I bring this up is that sometimes the first method is easy, but usually if these are only simple, most of the time the second method is what is going to be simpler for us to use. So I'll write that little note here that the second method is easier when the numerator and denominator are polynomials. All right. With that being said, our goal is to do a couple examples of each. So with this next one, I'm going to make them polynomials. X squared minus 4 over x squared minus x minus 6 times 3x squared plus 15x, and then over 6x squared minus 12x. All right, given that we've got polynomials here, the first thing we're going to do is factor. So I'm going to factor all 4 parts. And so when I say 4 parts, I mean the 2 numerators, the 2 denominators. So here's our factoring. X plus 2, x minus 2. This one, add, multiply. We're going to get x minus 3 and then x plus 2 times. Next one, we got a little GCF. Take out 3x. We're left with x plus 5 Last one, we can take out a GCF of 6x, and we are left with x minus 2, right? Once we've factored everything, I mentioned it before, we're going to treat it like one big fraction. And so if I think about this as one big old fraction, then all this stuff is multiplied, all that stuff is multiplied. So we are allowed to now simplify out or cancel any like terms. And now specifically from top to bottom, all right? So it's because we have an x plus 2 up top and an x plus 2 in the bottom, they're going to divide out. We're left with just ones. Same thing here for the x minus 2, x minus 2. See you later. In the top, we have a 3 and a 6. So that 6 we know can be broken into 3 times 2, and so we can cancel a 3 there. X divided by x, those are going to go. That's a common factor. So when we look, all we're left with in the numerator is just that x plus 5 times a bunch of ones. So really just x plus 5. In the bottom, we have the x minus 3 here. And we have the 2 here. There is no need to multiply back out your answer. And so I would leave it just like that. If you did multiply it out, it would read as x plus 5 and then over 2x minus 6. But I would suggest leaving it in the factored form. So leave the final answer in factored form. Don't make more work for yourself. The only time I would say you would ever multiply back out is if it was multiple choice and you didn't see that as a choice there, and then maybe you'd have to multiply out to see this, all right? Otherwise, let's try another one. So number 2, for this one here, we've got 6x squared times y cubed over 4x to the 5th y to the 2nd times 10 x y to the 7th, and then over 9x to the 5th y to the 7th. All right, you can use the second method here and just try to factor from kind of top to bottom. But I would say in this case, for monomials, all right, which just means single terms. There's no plus sign, and so on. All right, for monomials, method 1 may be easier. And so with that being said, I think it would actually be a little simpler to multiply together this first, multiply that together. Kind of just condenses everything, and then we can simplify it all in one step. So if we multiply the numbers, so 6 times 10 will give us 60. X squared times a single x, add those exponents, so x cubed. Y cubed times y to the 7th will give us y to the 10th power. And then all over 4 times 9, so 36. X to the 5th times x to the 5th, we add the exponents and get x to the 10th. Y to the 2nd times y to the 7th gives us y to the 9th. And now once we have it as one single expression, top and bottom, it's a little bit easier to be able to go from there, right? I would go one little part at a time. So with like the 60 and the 36, those are both divisible by 12. So I can either think of just dividing them by 12, or feel free if you want to show it as 12 times 5 and then 12 times 3, go for it. All right. That would allow us to cancel those, and we would get 5/3. As for the x's now, you're subtracting those exponents. So 3 minus 10 would give me x to the negative 7th. But I don't want to leave a negative exponent. That just means I'm going to have x to the 7th in the bottom. And then for the y's, subtract those exponents. 10 minus 9, I'm going to get y to the 1st, and it's positive, so it's going to stay in that numerator there. All right. We have one last example that's multiplying, and then we're going to switch on over to dividing. So last one, I think I can sneak it in here. Oh, well, we'll try. All right, let me slide my paper on down. So I have 2x squared plus 12x over 4x plus 8 times x squared minus 4x minus 12 over x cubed minus 216. All right, we're back to polynomials. So in this case, I think it's better to go back to that second method, which means factor first. All right, we can take out a GCF here, so 2x, and then left with x plus 6, and then take out 4, and you're left with x plus, 2. Over here, we can factor, add, multiply, so x minus 6, and then x plus 2. On the bottom, we got difference of cubes, all right? So we keep seeing these different factoring methods pop up. So that is going to be cube root of x cubed is just x. Cube root of 216. In case you're not sure, you own a calculator, right? So we can do the cube root. It's under the math key. So cube root of 216, that's going to come out beautifully as 6. And so that means we have x minus 6, second parenthesis, first term squared, product of the two, last term squared, both signs being plus. All right, now that we've factored everything, treat it like it's one huge fraction, and we can cancel any like terms from top to bottom. So up top, let's see, we've got an x minus 6 and an x minus 6. We have an x plus 2 and an x plus 2. And then we have a 2 and a 4. We can simplify that. So that's going to come down to 1 and then 2. Right? I think that's everything that we could do. So what we are left with on top is an x and an x plus 6. And then in the denominator, we've got the 2 from over here. And then that trinomial there, x squared plus 6x plus 36. There we go. All right. That is the last multiplying one. The last thing we're going to do is quick talk about some dividing. So let me grab myself a new piece of paper. And we are only going to do a few quick examples with this. So for dividing, you have to remember one simple little rule here. Any division problem can be rewritten as a multiplication problem. So we are going to rewrite the problem as multiplication. Sorry, I was making up my own spelling there. Right? Rewrite the problem as multiplication, and specifically multiplication by the reciprocal. So what we might remember with dividing fractions, if I have 1/3 divided by, let's say, 2/3, all right? You might have learned it as keep, change, flip, or same, change, flip, something like that. If I keep this first guy, it will stay 1/3. We're going to change this to multiplication, and then we'll flip the last thing. So flip it over, becomes 3/2. As soon as it's a multiplication problem, you know what to do. This one, we could just cancel those 3's and we'd be left with a half, right? If I give you one last one here, 1 over x squared minus 25, and then divided by 1 over 5 minus x. Right? All you have to do, keep the first part, but factor it. Right? So factor kind of as you go. Let's factor it. X minus 5, and then x plus 5 for that first part. That's difference of squares. Change that to multiplication. Flip this guy over. So that's now coming to the numerator. The 1 now comes down to the denominator. All right. If it helps, because that expression is already factored, put parentheses around it so we see it that way. And now we treat it like one big fraction. So anything from top to bottom that's the same can go. if you're savvy here, these are not exactly the same, the x minus 5 and the 5 minus x, but when they're the exact opposite around a subtraction sign, we can cancel and leave a -1 in its place there. And so we're left with -1 on top and then x plus 5 in the bottom. That is our final answer there. All right, it's a good place to stop. We'll do some more practice on the homework together.